Okay, so 11.2, we're going to talk about some other techniques. 11.1, remember, was the table method and a graph method. So now this method, this direct substitution, one of the things we want to know is that this function has a domain that's negative infinity to infinity. We have no issues with the domain, no breaks, no anything. So we can just go ahead and plug anything we want in there. And when you do that, you get negative 1 squared minus 1 minus 6, which is negative 1 squared is 1, minus 1 is 0, so I get negative 6 for my limit. So we don't have any worries. Now on this one, if we just did the 2627, which is a lot of times what we do in pre-calc, we set up the 2627 before this, you would grab the x plus 3 off to the side, set it equal to 0, subtract 3, and you'd find out we're going to have a problem if we try to plug negative 3 in. There's some undefined value. But notice they're asking us to approach negative 1. So the only problem I have is at negative 3. So go ahead and plug negative 1 in. And so again, this would be negative 1 squared minus 1 minus 6 over negative 1 plus 3. So that ends up being negative 6 over 2, which is a limit of negative 3. So again, in the next one, if I take that x minus 5 and set it equal to 0, add the 5 to both sides, I'm going to have a problem at 5. That'll be undefined. But they're asking us to approach 0, so go ahead and plug it in. 0 plus 1 over 0 minus 5. So 0 plus 1 is 1, square root of 1 is 1, over negative 5, so you could write negative 1/5 or negative 0.2. So these are all what we call direct substitution. Because we're not dealing with the spot where the error or undefined term is, we can just go ahead and plug it in. The arc cosine, if you put the 1/4 in there, it's really like, when is cosine 1/2? 2 times 1/4 is 1/2. So if you remember, cosine inverse only produces answers in the top 2 quadrants. So that's where cosine inverse works. And cosine is positive in these 2 quadrants. So the overlap is in the first quadrant. So when does cosine produce a 1/2 in the first quadrant? If you look at the unit circle, that's at 60 degrees. Okay, so now, again, we're looking at x plus 3 on the bottom. So if I take that off to the side, this is the same problem we did above. So when you subtract 3, I'm going to have a problem at negative 3. And once you know it, they're asking us to look at negative 3. So there must be some sort of technique, because when you put negative 3 in, you're going to get 0 over 0. 0 over 0 only tells you to try a different technique. 0 over 0 does not mean that there is no limit. So what we can do is rewrite this, the limit, as x approaches negative 3. You can go ahead and do the top is x plus 3, x minus 2, all over x plus 3. So see where the x plus 3 is on top and the bottom, that means there's a hole in the graph. But in this chapter, we're going to go ahead and get rid of those, and now we know that the graph actually behaves like x minus 2. But if you go ahead and plug the negative 3 in there, negative 3 minus 2 is negative 5. So that's the limit. Go ahead and try example number 2 on your own. Try to factor it out, because you'll notice if you put the 2 in there, it'll make this 0 and the top 0, and that doesn't mean there's no limit. So try the factoring. All right, so let's go over and look at these new techniques. If you factor the top, x plus 4, x minus 2, The x minus 2's will go away, and you're allowed to now plug the 2 in, so 2 plus 4 is 6. So hopefully you got a remainder of 6, or a limit of 6. I'm going to do the first one with you, and then you can look at how to do these because it'll be basically the same thing. It would make our life easy if this cubic had an x minus 1 factor in it. So for me, I would probably set up synthetic division 1, negative 1, so the 1 and the negative 1, and the 1 and the negative 1 again. Now, if x minus 1 is a factor, I put a 1 out front. So this will drop through, multiply on the outside, I get 1, add the negative 1 and 1, we get 0. 1 times 0 is 0, add, we get 1, and 1 times 1 is 1. And so I do get a remainder of 0, so that means it is a factor. Remember that this is your constant, this is your x, this is your x squared. So if I rewrite this, I have an x minus 1 factor on the bottom, and now the other part is x squared plus 1. So these two things go away. You're looking at the limit as x goes to 1 of 1. Got to keep the 1 there because you really divide out the x minus 1. You don't just make it 0, so it's dividing out. And on the bottom it's x squared plus 1. So now put the 1 in there, and you get 1 plus 1 on the bottom, so you get 1 over 2. I would try example 4 and 5 as DIYs. Test by synthetic division. Remember, this would be 1, 0, 0, and a negative 1. This would be 1, 0, 0, 343. See if you can set up synthetic division, figure it out, and then come back and check your answers. Okay, so hopefully you had a chance to go in and do the cubic, so let's go ahead and check your answers. So on this one, if you set up a synthetic, you could do your polynomial long division to see if it's there, but I would do this one. So I went 1, 0, 0, negative 1. I think x minus 1 is a factor, so I put the 1 out there, and then you do the work. This is your remainder. So it works. The remaining, though, is x squared x plus 1. So x minus 1 was a factor, so you can cross that off, and now you're left with this. And it's the limit as x goes to 1. So when you put a 1 in all these, you should have got 1/3. And again, you can do 1, 0, 0, 343. Put the negative 7 over here, do all the work. There's your remainder. So x plus 7 was a factor. X squared minus 7x plus 49 is what's left. Cross off the x plus 7s, and then you have this. And when you put a 7 in for each one, you have 1 over 49. Final answer. This one's a little bit goofy. We just have to add the numerators first. So their two denominators are different. So I need to create a common denominator by taking the x plus 4 from over here to the top and bottom. So we're going to multiply it by that 1/4. And then I need to take 4, top and bottom, over here. So it's kind of messy, but it looks like this. Limit as x goes to 0. Now my common denominator is 4x plus 4 all over 4 times 1 is 4, and when I take this negative 1 and I distribute, I get negative x minus 4. Now I still have this thing down here, I'm dividing by an x, so instead I'm going to multiply by 1 over x. So these go away, and you have negative x over 4, x plus 4 times 1 over x, and now the x goes away, and we're looking at what is the limit as x goes to 0 of negative 1 over 4x plus 4. So this is the first time that we can put the 0 in, and I'm left with negative 1 over 16. So not too bad once you get going, but the key is taking the x plus 4 top and bottom, this 4 top and bottom, to create the common denominator. All right, so the next technique is what we call a rationalizing technique, because if you put 0 in, you get 0 on top and you get 0 on the bottom, so we have to do something different. So I multiply by what we kind of call the conjugate. So it's the square root of x plus 2 plus the square root of 2, and you need to do that on the bottom also. So this is the limit as x goes to 0. Now when I take this square root times that square root, I just get x plus 2. When I take negative root 2 times root 2, I get negative 2. And on the bottom, I'm just going to do the square root of x plus 2. I'm going to just do this x times now this stuff. I'm just going to write them next to each other. Now up here, when you talk about foiling, I didn't have to do the FOIL because they're conjugates, so don't worry about the O and the I. So the 2's will go away. And now the x's will go away, and we still have the 1 on top. That's a 2. And now when I put the 0 in, I finally am ready to simplify, and it's 1 over the square root of 2 plus the square root of 2. So that means I have 2 root 2's, and we don't want the radical on the bottom, so that's the square root of 2 all over. Square root of 2 times square root of 2 is 2 times 2 is 4. Final answer. All right, so let's do it one more time, then you can try 2 more examples on your own. So we're going to multiply by 1 plus the radical over 1 plus the radical. So this is the limit as x goes to 0. So now, again, we're foiling, but it's conjugates on the top, so you just have to do the 1 times 1. Now be careful, this one, there's a negative, but we want to put 1 minus x in parentheses here, and then we're going to just write the x next to all of this. Now, when we distribute the negative, this becomes negative 1 plus x. So the 1's go away. And I have that positive x on top. Then the x's go away. And so you have the limit as x goes to 0 of 1 over and at this point now with the x gone, we can go ahead and plug in the 0. And 1 minus 0 is 1, so that's the square root of 1, which is 1, and you end up with 1 over 2. All right, the next two are labeled DIYs, so go ahead and try them and come back and check the answer. Okay, so hopefully I had time to do 3 and 4 DIYs. Let's go over here and look at the answer. So again, multiply by the conjugate on the top and bottom. We're coming right down here. Just write those two next to each other. The top turns into x plus 25 minus 25, so the x's go away, 1 over that. Square root of 25 is 5 plus 5, 1 over 10. Do it one more time. Radical plus 1 on top and the bottom. Multiply this to give you this. The 1's go away, the x's go away, and you have 1 over this radical plus 1. Finally, we can put that 0 in for the x, and you end up with square root of 1 plus 1, or 1/2. All right, so the last couple here, on this page, we're going to just go to our calculator, and there's still some things that are just beyond what we can do. So you're going to type in for y equals 1 plus x raised to the 1 divided by x. And I would look at a table, and we're supposed to get close to 0. And you can go 0.0001 if you want. And now look at the actual table. So you can see the error that's in the middle. And this number is 2.718 on both sides. So you can write that down. Which is getting close to what we call E, but we still looked at the table. And then the last one on this page, trig function, you do sine of x, and you divide by x, and our table should work. Start at 0, go small, but then you're going to have to move stuff. So if I just look at the table, you notice that's 1 on both sides.
Good afternoon, Royals.
So after you do the table, you got approximately 1 on both sides. All right, so try example 3. It's a DIY. Type that into your calculator, make sure you're in radian mode, and then come back and check the answer. All right, so hopefully you typed that in, looked at it. The graph is a little bit crazy. Bunch of S's kind of over here and a bunch of S's over here, but there's this nice little U in the middle, and that comes down and touches 3 and then goes back up. And you can also look at the table, but the limit right here is 3. These two examples, we'll talk about some one-sided limits, so I'm going to have you graph these, and piecewise function. So I'm going to do this one in blue. So what we do is we make a table, probably the easiest way, and I'm not really supposed to use 1. I'm only supposed to use numbers less than 1, but I'm going to use the 1 knowing that there will be an open dot on my graph. And now numbers that are less than 1 would be 0, -1, -2. And fill in a table until you know what's happening. And this is a linear. So when I put in 1, what's 4 minus 1? That's 3. What's 4 minus 0? That's 4. What's 4 minus -1? Well, that's 4 plus 1, or 5. So I have a pretty good idea of what that graph is doing. So I go to 1, 3, and I'm going to put an open dot. Then I go to 0, 4, and then -1, 5, and I draw my straight line. I'll do this one in purple, and same deal. This one, though, is a U-shaped graph opening down, and so it's starting at 1 again, but I'm not supposed to use 1, but I'll put an open dot on my graph, and then numbers that are bigger. So we're going to go 2, then 3, then 4. So if I put a 1 in for both x's, I get 4 minus 1, that's a 3. 4 times 2 is 8, and 2 squared is 4, so 8 minus 4 is 4. Put in the 3, I get 12 minus 9, which is 3. And if I put in a 4, I get 16 minus 16, which is 0. So 1, 3 is this open dot. 2, 4 is up there. 3, 3 is here, and 4, 0 is here. So I can tell my parabola is going like this. Now, we're supposed to find the limit as x approaches 1. Well, this is 1. And there's this overlap here at the open dots. And so the limit as x approaches 1 is actually sitting at 3, an output of 3. All right, so we're going to do the same thing on this problem, except I'm going to ask you to switch this to an 8. So if I do this graph, I make an XY table. Again, I'm going to start at 2 and do numbers that are smaller. And this first one is going to be open because I'm not really supposed to use it. So 2 squared is 4 plus 1 is 5. 1 squared is 1 plus 1 is 2. 0 squared plus 1 is 1. Now negative 1 squared is 1 again, plus 1 is 2, so I can see that it's going back up. So I can graph that. So 2, 5, 1, 2, 0, 1, negative 1, 2. So I know that's supposed to be an open dot, and it's coming down and going back up. Now the red stuff, remember I'm going to have you switch to 8. And so when I make this XY table, I'm only going to do even numbers. So I'm going to start at 2 and do numbers that are bigger. Because of this 1/2, it'll just be easier to do even numbers. So negative half of 2 is negative 1, plus 8 is 7. Negative half of 4 is negative 2, plus, negative 2 plus 8 is 6. And negative half of 6 is negative 3, plus 8 is 5. So 2, 7, open, 4, 6, and 6, 5. So we get a graph that's kind of looking like this. Now what's different about this is if I do the limit as x approaches 2, it does not exist because there's space between those two spots. But the problem that we're supposed to do is what happens if x approaches 2 from the negative. I don't know if you can see it, but it has the 2 to the negative, and that means go from the left-hand side. So as you get closer this way, my outputs are there. So that one is going to 5, and I could even do this to what happens as x approaches 2 from the positive side. Well, that would be following this line, and you're going to be at 7. So that's why I had you change this number to 8. It separates the two openings. All right, so there's one more. Try graphing it, and then come back and check your answer. All right, so if you went over and did these two, this one would be kind of similar to what we did up above. But if somebody asks you to approach 4, you could just put 4 into both of these. And when you put 4 in, you get 10 over here for this one. And when you put 4 in here, you get 8. And because they don't agree, the limit does not exist. But if you did 4 from the negative side, it would be 10. If you did 4 from the positive side, it would be 8. And it's just a matter of what side of the function are you using, this 4. So on the smaller side or negative side, you use the linear. And on the positive side, you use the quadratic. That's it.